this lesson, we're going to graph polar equations, specifically Rose curves and Lemniscates. For a Rose curve, your equation is going to be in the form of r equals a cosine of n theta, or r equals a sine of n theta. For Rose curves, you can see that you look at the value of n is the number in front of theta. If n is even, then the Rose curve will have double that number of petals. If n is odd, the Rose curve will have exactly that same number of petals. The number in front, the a value, is going to be the length of each petal. If the equation has a sign in it, then you're going to figure out where the first petal is fully extended by essentially taking the a value, plugging it in for r. When you divide both sides, you end up getting 1 equals sine of n theta, and then you solve for theta. However, every single time you do this, what's going to happen is you're going to eventually say sine of what angle equals 1, and that's going to be pi over 2. So then you essentially take the inside, which is n theta, set it equal to pi over 2, and you can see that if you take this equation and divide both sides by n, you end up getting that theta is equal to pi over 2n. So the nice thing is, anytime you have an equation for a Rose curve that has a sign in it, the first petal is going to be fully extended using this formula. It's going to be at the angle pi over 2n. The other nice thing is anytime you have cosine as your equation for your Rose curve, then the first petal is going to be fully extended at theta equals 0. So it stays consistent with our previous circles where cosine is going to lie along the x-axis for the first petal. And again, sine, to find where the first petal is fully extended, you can use this formula. It's just pi over 2 times the n value, and again, n is the number in front of theta. Finally, you're going to rotate each petal. So once you get that first petal graphed, then you can rotate each petal, and the way you figure that out is you take 360 degrees and you divide by the number of petals, and that will tell you what angle to rotate the next petal to. Here we have a couple of Rose curves graphed out, so you have it as your reference. Just for a nice visual, it says r equals a sine of 2 theta, n is 2, and you'll notice that there's 4 petals because 2 is n is even. The number of petals would be 2 times 2, which is 4. Here's an example where it says r equals a cosine of 3 theta. 3 is n is an odd number, so then there's going to be 3 petals. For this equation, we have n is 4. 4 is an even number, so then you times by 2, you get 8 petals. And here's an example where n is 5. It's an odd number, so therefore you have exactly 5 petals. So one more time, if the n value is even, like these, then the Rose curve will have double that number for the number of petals. But if n is odd, like 3 and 5, then the Rose curve has exactly the same number of petals, which in this case would be 3, and this one would be 5. The other thing I want to point out is right here, it says sine of 2n. So you can see this first petal is fully extended. And again, that formula was pi over 2n. So you go pi over 2 times 2 is 4. So the first petal is fully extended at pi over 4. This equation has a cosine, and the first petal is fully extended at x equals 0. So that's really convenient. And then again here, cosine, the first petal is fully extended at 0. And this last one, you can see the sine, and its first petal is fully extended using the formula pi over 2n. So that's going to be at pi over 2 times 5, so pi over 10. So that's why this first petal starts right here. For this next example, it says graph the given polar equation. So I wrote down an number of petals. A is the front number, so a is 4. N is the number in front of theta, so n is 2. 2 is an even number, so therefore the number of petals is going to be 2 times 2, which is 4. We're going to look at this equation. It says sine. So to find where the first petal starts, we're going to use the formula pi over 2n. So I wrote first petal, and it starts at pi over 2 times n. N is 2, so then you get pi over 4. So the first petal starts at pi over 4, so that's right here. And then the a value tells you how far out to go. So here's our first petal. To find how to rotate the petals, you're going to do 360 divided by the number of petals. So we'll go 360 divided by 4, and you get 90. So we're going to rotate 90 degrees for the next petal. And you can see that I did the next petal, and I still went out a same length of 4, and then I'm going to do it again for another 90 degrees, and then one more time to get our 4th petal. And there's our first Rose curve. All right, so a is the front number, so a is 2, and n is 5. 5 is an odd number, so that means it's going to have 5 petals. So one more time, if n is even, then you have double that number of petals. If n is odd, you have the same number of petals. Next, we're going to glance back at the equation. It's a cosine, and cosine's first petal is going to start at 0. So first petal starts at 0, so we'll start right here. The length is going to be a, so we're going to go out 2 units. So there's our first petal. Next, to figure out how to rotate, we're going to do 360 divided by the number of petals. All right, so we get 360 divided by 5 is going to be 72 degrees. So I'm going to rotate this to about 72 degrees and then go out a length of 2. This is 45 degrees, this is 60 degrees, so we're going to go a little past that to get to 72 degrees. And again, I went out a length of 2. And we'll just keep going all the way around so that we get all 5 petals, rotating 72 degrees in between each petal. So 72 plus another 72 would be 144. Which is going to fall like right around here. And then I'll just keep rotating another 72 degrees to get the last 2 petals. All right, and here's our final rose curve, r equals 2 cosine of 5 theta. This next one says r equals 3 cosine of 4 theta, so we'll start it the same way by identifying a, n, and the number of petals. And I'm going to go ahead and fill it in. A is 3, n is 4. 4 is even, so there's going to be 8 petals. The equation has a cosine in it, so the first petal is going to start at 0. And then we're going to rotate 360 divided by the number of petals. So now that we have everything identified, let's go ahead and graph it out. So here's our first petal, and it's a length of 3. Then you rotate 45 degrees, go out 3, and we'll keep going all the way around till we have 8 petals. And here's our final rose curve. You can see there's 8 petals, it's cosine, so it starts at 0, and then there's 45 degrees between each petal, and each petal is a length of 3. All right, moving on to the next one, we'll go ahead and get it set up the same way. Okay, so we have a is 5, n is 3. 3 is odd, so we're going to have 3 petals. The equation has a sign in it, so to find where the first petal is fully extended, we're going to use the equation pi over 2 times n. So the first petal will be fully extended at pi over 6. And finally, to figure out the rotation, we're going to go 360 divided by the number of petals, which is 3. So we're going to rotate 120 degrees. So first petal fully extended at pi over 6, and we'll go out a length of 5. And again, pi over 6 is the same as 30 degrees. So then we rotate another 120. So that puts us at 150, so 150 degrees gets us here for the next petal. Starting at 150, we're going to add another 120, so that gets us to 270, which is down here. And there's our rose curve with 3 petals. The next graph we're going to cover is a lemniscate, and you'll see the lemniscate looks like a propeller, and so when you have the formula with a cosine, the propeller will lie along the x-axis. When you have sine, the propeller will lie along the line pi over 4, or at 45 degrees. And the nice thing is those are our only options. It's really important to recognize that this equation for a lemniscate, it specifically says r squared equals a squared cosine of 2 theta. And this one says r squared equals a squared sine of 2 theta. A couple of things to note, this will always be r squared, so that's kind of a nice little tip that it's a lemniscate. Also be careful because right here it says a squared. So if this value here says 25, that means A, the length of the propeller, is going to be just 5. If this says 9, the length will be 3. If you'll notice, I'm taking this value, square rooting it, and that gives us the length of the propeller. If this said 7, then the length would be the square root of 7. And then the other thing to just make a note, this equation always has cosine of 2 theta. So if you ever come across an equation where it doesn't say 2 theta, but there is an r squared, then that means it's going to be a different shape. This example says consider the polar equation r squared equals 4 cosine of 2 theta. So again, you can see that this is in the format for a lemniscate. You have the 2 theta, you have r squared equals, and then this is your a squared. So again, if this is a squared, that means A is 2. Propeller length would be a length of 2. The first part says check for symmetry. So first we have the polar axis. To check for symmetry of the polar axis, you plug in negative theta for theta. 2 times negative theta is going to make negative 2 theta. And then from our even odd functions from the previous lesson, cosine of a negative angle is equal to positive cosine of the angle. So here we have r squared equals 4 times cosine of 2 theta. Because this is identical to the original equation, this equation does have polar axis symmetry. So I just wrote yes for polar axis symmetry. Okay, next we're going to do theta equals pi over 2. So I plugged in negative r for r, and I plugged in negative theta for theta. We just did this exact work on this one, so I'm going to just copy down the right side. And then finally, negative r squared is going to be positive r squared, because a negative times a negative is a positive. And since this is identical to the original equation, the graph does have symmetry about the line pi over 2. All right, and then I'm going to move on to the pole. So we're going to replace r with negative r. And again, we just talked about doing this. Negative r times negative r is r squared. And again, you get the same equation as the original, so this graph does have symmetry about the pole or the origin. All right, so we have symmetry about all three. Let's go ahead and graph. This is a cosine graph, so it's going to lie along the x-axis. This value is a squared, so therefore a is 2. So I just made a note that this is a squared, so I wrote a squared equals 4. And when we solve this, we square root both sides. And so I put a plus or minus here, and then we'll get a equals plus or minus 2. So I graphed one side of the propeller, and we'll do the other side. And here's our graph of the lemniscate, r squared equals 4 cosine of 2 theta. This example says graph the polar equation, r squared equals 9 sine of 2 theta. And so you have sine, the sine lemniscate always lies along the line, pi over 4. Here is a squared, so we get a squared equals 9. So therefore, a equals plus or minus root 9 or plus or minus 3. So along the line pi over 4, we're going to go out 3 in both directions. And here's your lemniscate for the equation r squared equals 9 sine of 2 theta. All right, guys, thanks for watching, and hope you have a great day.